Reaction mechanism, SN1, predict the product, maybe two products, three, formed by the solvolysis of 2-bromo-2-methylpentane with ethanol. Okay, so let's unpack this a little bit. So first of all, we are told that maybe we will have more than one product. In this one, we don't know yet until we start solving this. And then the next thing we are told is solvolysis. Solvolysis means that the solvent is actually taking part in the reaction. And then of 2-bromo-2-methylpentane, of course, that's going to be our substrate, okay, that we have with ethanol. So ethanol is a very common solvent, so which means that's the solvent I'm going to be using in order to do this reaction. You don't really clearly see any kind of a nucleophile, and that's because this is an SN1 reaction. So the solvent is the nucleophile. Okay, so let me write that over here. So solvent is the nucleophile. That's how you work with solvolysis. Okay, so let's get started. So we have 2-bromo-2-methylpentane, so which means this is pentane, and we have 2-bromo-2-methylpentane. Okay, that's what we have. So now we are told also that this is SN1. And by the way, even if it doesn't tell you that it's SN1, as soon as you see solvolysis, solvolysis is a big clue that it's going to be an SN1 mechanism, because in SN1 mechanisms you don't need to have a good nucleophile, okay, because it's not part of the transition state. All right, so you don't need it. You need to have a good leaving group, okay, and so which means that the bromide leaves, okay, over here, and now we have a carbocation. Now, if you're wondering how did my methyl group move, it didn't really move. It's all single bonds. Things can rotate around. I can draw something like this also, and this will just look super awkward. Okay, so I don't want to draw chicken feet for me. I want to draw nice open structures. Okay, so I can clearly see all the bonding, okay, going on. All right, so now I need to have the nucleophile coming in, and the nucleophile I have is ethanol, and ethanol is C2H5OH. So with ethanol, where are my electrons? My electrons are on the oxygen. So the oxygen then will come here and attack this, and so now I have this. Oxygen is attacking the carbon, so which means the bond is between oxygen and carbon. On the oxygen, I still have a hydrogen. On the oxygen, I still have the ethyl group. Okay, but now my oxygen actually has 3 bonds, which means that oxygen has a formal charge of plus, okay, in this one. So now I need to relieve the poor oxygen of the plus charge, okay. And by the way, this oxygen right here, this is called the oxonium ion. You're going to see this a lot, okay, and so might as well get used to it. So now that you have the oxonium ion over here, I need to relieve that of the positive charge. So what do? I bring in another ethanol molecule. And so now that other ethanol molecule is going to pick up a proton. So picking up a proton is an acid-base reaction kind of a thing. So in this case, my ethanol is a strong enough base to pick up this proton. Okay, why? Because it's an oxonium ion, okay, that I'm taking the proton from. So it's easy enough to do. Okay, and so then my final product is going to be this C2H5. So do I have any other products? No, I don't. Okay, so don't be fooled when it says products, and that's also the S in the brackets, which means maybe, maybe not. So in this case, it's a not. Okay, so this is it. This is the product I get, and then this is the mechanism, okay, for this. Now, when we write the mechanism of anything, please remember you got to draw the arrows out. If you don't draw the arrows, it's not a mechanism. Okay,